Hello, everyone. Welcome to episode 64 of Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Adrift by Gerhard 1963. Oh, well, it's too bad it's not episode 63 for Gerhard 63, but yeah, we're one off. That'll work. And here are the rules. Standard Sudoku rules apply. The digits 1 through 9 appear in every row, column, and box. Crop key pairs. Digits in cells separated by a black dot are in a 3 to 1 ratio. So this is not your typical crop key pair, crop key dot, right? And they're specifically marked as 3, though, so that you can remember that this is not a typical black crop key dot. And it has to have a 1 to 3 ratio between two digits separated by a black crop key dot. Digits in cells separated by a white dot have a difference of 3. So similarly here, the white crop key dot has to have a difference of 3 instead of 1. So as examples here, actually let's finish reading the rules for that. Not all dots are necessarily given. So as an example, if this were, say, a 3, this would have to be a 1 and or a 9. We would celebrate because we would know it's 1 or 9 in the adjacent cell next to it. But it has to maintain a 3 to 1 ratio since there's a 3 in this black crop key dot. Similarly, if this were, say, a 4, this would have to be a 1 or a 7 because we know that the difference between these cells must be 3. And that's how this variant of crop key pairs works, because it's marked specifically with 3s everywhere. We also have arrows, where digits along an arrow must sum to the number indicated in the circle from which the arrow emerges. So the digits along the arrow, which would be just this digit, must sum to the number indicated in the circle from which the arrow emerges, which would be that circle. That will give you certain things that you know have to be true about these two cells. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. So let's learn how to Sudoku. Okay, I'm not really sure how we should tackle this. Let's tackle it the places where you have 3 cells which are separated by 2 black crop key dots, separating the 3 cells. This has to be a 3 because there's only one digit that can be in a 1 to 3 ratio with 2 other digits, and that's 3 with 1 and 9. The other pair you can have on a black crop key dot that has a 3 to 1 ratio is 2 and 6. But since there's two 2 to 1 ratios here, this has to be 3, which forces this to be 1 or 9, this to be 1 or 9. So similarly, this is 3, with this being 1 or 9, and this being 1 or 9. The digit next to it has to be 3 away from it. So if it's 1, it has to be 4. If this is 9, it has to be 6. Similarly for this, if this is 1 or 9, this has to be 4 or 6 also. So this is 4 or 6, and this is 4 or 6. This 4, if this is 4, it could be either 1 or 7. If this is 6, it would have to be 3 or 9. We're not sure which. Similarly, this would have to be 1, 3, 7, or 9 also. We know these two digits are the same, and we know these two digits are the same. That's what I was saying when you have arrows. Hmm. Okay, what else do we know? Oh, this has to be 4 or 6, but this has to also be 4 or 6, but they cannot be the same one, right? If this was 4 and that was 4, these would both have to be 1, which is not allowed. So therefore, this can never be 4 or 6 because it sees both varieties of the 4 or 6. So this has to be, let's mark this as A, I guess. We'll make that A. This has to be A. Actually, this cannot be A, so this is the B version of that. We'll make that C and D. We don't know anything else here, though. This, again, cannot be 4 or 6 here. The rest of this box... do we go that way? I don't know. These, okay, let's mark these. These have to be 1, 2, 3, 6, or 9. And these are 1, 2, 3, 6, or 9. 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 These are 1, 2, 3, 6, and 9. These are 1, 2, 3, 6, and 9, but this can't be 3. So since this can't be 3, this can't be 1 or 9. So this is specifically 2, 3, or 6. This can't be 3, so this can't be 1 or 9 here. What is 3 away from 1, 2, 3, 6, or 9? You can only have 4, 5, or 3, 6, or 9 here. Right? So this can never be 9. Well, it could be. This could be 3, 9, and that could be 6. Hmm. Um, okay, so this is 1, 2, 3, 6, and 9. So similarly, if it's 3 away from 1, it's 4. If it's 3 away from 2, this has to be 5. If it's 3 away from 3, this is 6. If it's 3 away from 6, it's 3 or 9. And if it's 3 away from 9, it's 3, 6. So, and again, this cannot be 4 or 6. Similarly, you have a similar thing here. So this has to be 3, 5, or 9 also. Because again, both of 4 6s here cannot be the same, because then if this was 6 and 6, this would have to be 9 and 9. If this is 4 and 4, this would have to be 1 and 1, which is not allowed. Um, hmm. Anyone that's 3 away from each other has to be in the same modular set. When by modular set, I mean specifically if you divide the number by 3, you would get either modulo 0, which is a remainder. So say you had 3, 6, or 9. You divide by 3, you get a remainder of 0. Or if you had 1, 4, or 7, it's 1 modulo 3. Or if it's 2, 5, 8, it has to be 2 modulo 3. So these have to be the same sets, essentially, if that's the case, right? Because these are 3 away from each other. So if it were 3, obviously, or 6, or 9, it can only go to 3, 6, or 9. If it's 2, 5, or 8, it can only go to 2, 5, or 8 to be next to it. And if it's 1, 4, or 7, it can only be next to 1, 4, or 7. So these sets are the same. This one has to be different. And therefore, these two sets are the same. Let's make it yellow. These 3 sets have to be the same. And these 3 sets have to be the same. Actually, let's make this green and this red. Therefore, these cannot be green. They could be red or something else. Not sure if that's helpful. These can't be green either, because there's 2 greens in the same column. Therefore, they have to be a different color. It could be red or it could be some other color. We're not sure. Okay, one thing we know then is this can never be a 3-9 pair, because that would eliminate 3 and 9 from both of these cells, which would make both of them 5. So this cannot be 9 and 3. If this is 6, this could be 9 or 3. So either this is 1, 3, or this is 2, 6. We don't know which. Right? If it's 1, 3, this is forced to be 5, 9, and 5, 9. Oh, that's another thing. This can't be 4 or 6, right? So this can't be 4, which means this can't be 1. If it's 3, this would have to be 6. If it's 5, it would be 2. If it's 9, it's 6. So this is always 2 or 6. Same here, right? So if this is 3, 3 away from 3 is 6 only. 3 away from 9 is 6 only. 3 away from 5 would only be 2 out of the digits that can be in the 3-to-1 ratio. So this is 2 or 6, which forces this to be 2 or 6. Similarly here, this is 3, 5, or 9. The 3 can only be 3 away from 6. The 9 can only be 3 away from 6. And the 5 can only be 3 away from 5. So this has to be 2 or 6 also, which makes this 2 or 6. We have a 2, 6, 2, 6 pair now in this in column 3, column 7, this box, and row row 5, which eliminates 2 and 6 from the rest of the row. So this has to be 1, 3. We now have a 1, 3, 1, 3 pair in the central box, which eliminates 1 and 3 from the rest of the box. So this can't be 3, this can't be 3. This can't be 6 because of the 2, 6 pair in the box, so this must be 4. 4 can only be next to 1 and 7. That is 3 away. This has to be a 1 then, which makes this 9. This therefore has to be a 6. This cannot be 1 and 3, and it cannot be 2 and 6 because of the 6 here. So this has to be 3 and 9. This can't be 6, so this must be 4, which makes this 1 or 7. This can't be 1. Or sorry, this has to be 1, which makes that a 9, which makes that a 6. This can't be 1 and 3. This can't be 2 and 6. It has to be 3 and 9. We have a 3, 9, 3, 9 pair in column 5, which eliminates 3 and 9 from the rest of the column. Therefore, this can't be 3. This has to be 1. This makes that a 3. The 1 is 3 away only from 4, so this is 4. These can't be 2 or 6. Where are the 2 or 6s in the rest of this box? It has to be here and here. Because again, this can't be 2 or 6 because we have the 2, 6 pair here. This can't be 2 or 6 because of the 2, 6 pair. Therefore, neither of these can be 2 or 6. Therefore, this is 2 or 6, and this is 2 or 6. And this has to be 7 or 8. This is 7 or 8. Okay. So 9 has to be one of these cells, and this can't be 9, right? We have a 3, 9 pair here, which eliminates 9 in the rest of the row. In the rest of the box. We have a 9 here, which eliminates 9 from the rest of the box. And this can't be 9 because of this 9. So therefore, this has to be a 9 then, which means this is 9, which we can only be in a 1 to 3 ratio with 3. So this is 3. Similarly here, this is a 9. That's 3 in the corner. We celebrate. The 9 here eliminates 9 from the rest of the box. The 3, 9 pair eliminates 9 from the rest of this box. So where is the 9 here? Can't be here because of this 9. Can't be here because then that would have to be 3, which is eliminated there. So it must be here. So this is 9, which makes that 3. And we celebrate. Where can the 3 be in column 3 now? Can't be any of these because of this 3. Can't be any of these. Can't be here because this has to be a 2, 6 pair. Therefore, this is a 3, and this is a 3. These 2 digits must have a difference of 3. You cannot have 3 and 6. You cannot have, so therefore 9 does not have a digit that I can go 3 to. You cannot have 4 with 1 or 7 because the 4 is in the box. So this has to be a 2, 5, 8 triplet, or 2, 5, 8. And it cannot be 2 because of the 2, 6 pair in the box. So this must be 5 and 8. So this is similar too. This has to be 5 and 8. Let's remove the coloring because we don't need that right now. Well, okay, let's color them different, shall we say. Okay, so the 1 mod 3s we're going to make green. So these are all green. This is green, and these have to be green. The 2 mod 3s we're going to make pink. So these are both pink. These are both pink. And the 0 mod 3s we're making blue. So these are blue. These are blue. All of these are blue. So all of those are already done. These are blue. These are blue. And these are blue. This is blue and pink. This is blue and pink. This is also blue and pink. and this is blue. The remaining digits are 7 and 9. So this is 7 or 9. This is 7 or 9. And this has to be 1, 7 or 9. This is also 1, 7 or 9 because of what's in the box already. Remaining digits here are 2, 6, and 7. This is 2, 6, or 7. These are 2, 6, or 7, and this is 2, 6, or 7. Well, 6 cannot be next to any of these white Kropke pairs because it would have to be with 3 and 9, and 3 and 9 are not in the box. Or sorry, are already in the box. So one of these is a 6, therefore this can't be 6. Similarly here, one of these is a 6, so this can't be a 6. This cannot be 179 because of the 179 triplet here. Can't be 3, 6, or 9 here. So this cannot be 4 with 1 or 7. So it has to be 2, 5, or 8 here. Similarly, this is 2, 5, or 8. So one of these is a 5 because there's no other place for it. Or specifically, 2 and 5 can only be the one that could be connecting to 2 or 8. To be 3 away from that. This has to have a 4, so this is 4 with 1 or 7. So 4 has to be one of these, which makes this 1, 4, 7. So these are all green. These are pink. These are all green, and these are pink. This can't be 6 because of this 6. Therefore, this is a 6. This has to be the 6. Same here. This can't be 6, so this must be a 6. This can't be 6 here because of the 2, 6 pair. This can't be 6 here, so this must be a 6 in the corner, and this is a 6 in the corner. And those are all the blues then. 4, 7. This can't be 3, therefore this must be 9, which makes that a 3, which makes that a 9, which makes that a 3. This 9 means this can't be 9, so this has to be 5. And 5 is 3 away only from 2, so this is a 2, which makes that a 6. This can't be blue, this can't be 2, so this is 6, which makes that a 2, which makes that a 6, and that a 2. This has to be a 9. So this is not pink. Not pink. This is not blue here. This is not pink. And this is not blue. This can't be 5, so this must be 8, which makes that a 5, which makes that 8, which makes that a 5. This can't be 9 anymore. So now we have a 1, 7, 1, 7 pair here and here. So this can't be 1 or 7, therefore this must be 8, which makes this a 7. Therefore, this is 7. This has to be 8. This can't be 7 here because of that 7, so this is 1, which makes that 7. This has to be a 9. That makes this a 7, which makes that a 1, which makes this a 9. This cannot be 8 here, so this has to be a 2, 5 pair here, which eliminates 2 and 5 from the rest of the box, so this can't be 2, so this is 7, which makes that a 2. So this is the last pink, this is blue, and this is green. These are pink, these are green. This is pink, blue, blue. This is green, This is blue. This is not pink. And this is blue. Blue. This has to be a 1-4 pair. This is a 1-4 pair. So this is pink and this is pink. Because those are the only digits remaining. This is a 1-4-7 triplet. So the remaining ones are pink and pink in column 7. This is pink, which makes that pink, which forces that to be pink. This one of these is green, but this can't be a 7. So where's the 7 in column 3? It has to be here. So this is 7, which makes this a green, and therefore this must be a green. This can't be pink anymore because we have 3 pinks in the box, so this must be a 7, which makes this a 2. This can't be 2, so this has to be a 5-8 pair, which forces this to be 2, which makes that a 5, which makes that a 2. This 5 means this can't be 5 or 2, so this must be 8. This is 5 or 8, and this is 5 or 8, but this can't be 8. So this must be 5, which makes that an 8, which makes this a 5, because it's 3 away from 8. This cannot be 4 or 7, so therefore this must be 1, which makes this a 4, because it's 3 away from 1, so that's a 1. The remaining digits here both have to be pink, and one of them cannot be, this cannot be 2, so therefore this must be 8, which makes this a 2. Whereas the last 2, we have 8 of them. It has to be here, so this is 2, and it's therefore pink. The remaining cells in this box have to be green, because it's 1 modulo 3. This has to be 4, because it's 3 away from 7, which forces this to be 1, which makes that 4, which makes that a 1. Therefore, this has to be 7, and this has to be 4. This is green. This has to be green also, and is 4. This is pink. This has to be pink, because that's the only type remaining, so this must be a 5, which makes this an 8, which makes that a 5. This is green, and a 4, and this has to be pink and an 8. Which makes this a green, and it's 7, and this must be pink and 5. Cool and rare. Yeah, this was actually a little bit more difficult. Probably because I haven't done very many 3-to-1 ratios very often. So it was kind of, I was sort of, in a sense, making it up as I was going along. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.